Bismillah Rahman Rahim. Hello everyone. Welcome back to the another tutorial. So in today's tutorial, I will cover MCQs from MCQs 21 up to 30. So let's start from the first MCQs. Which of the following curves represent the speed torque characteristic of a DC series motor? So actually, my torque is directly proportional to flux times IA, and the speed is inversely proportional to the flux. So you can say that the torque is inversely proportional to speed. So the curve will be like this. So here we have speed, here we have torque. So option A is the correct answer. Okay, next MCQ is the type of DC motor control preferred for applications where unusually wide and very sensitive speed control is required will be armature control, Ward-Leonard control, voltage control, flux control. So the correct option is option B, Ward-Leonard control. Okay, so let's explain it a little bit more. Ward-Leonard control. This motor, Ward-Leonard control, is used for controlling the speed of DC motor. And this motor consists of DC motor. Okay, it consists of DC motor powered by a DC generator. Like this. Here we have DC motor, and it is powered by DC generator. And DC generator is powered by constant speed motor. So, and this constant speed motor is powered by DC supply. So this is my DC supply. And let's say this is my M2. So here we have shunt feed. This is shunt feed. So, and here we have this is my motor M1. This is M2. Okay, so M1 speed vary by varying the generator voltage, and generator is running by motor M1. So by controlling the voltage of G, by controlling the voltage of this generator G, the speed of motor M1 can be controlled. And we control the output voltage through field regulator. Through field regulator, we can control the output voltage, which control the field excitation. Okay, your field regulator will control the field excitation, and through field regulator we control the output voltage, and through output voltage we can vary the speed of this DC motor M1. And the direction of motor M1 can be reversed by excitation current, and it can be done with the help of this switch. This is RS switch. So it is used there. So this Ward-Leonard control motor used there, where a wide and very sensitive speed control of a DC motor in both direction is required. So the correct option is option B, Ward-Leonard control method. Okay, next MCQ is which curve represent the efficiency of a DC motor? So that is the curve D. So for low horsepower, your efficiency is increased. But if you increase the horsepower, then the efficiency will get decreased, because if you increase the horsepower, if you increase the horsepower, then it means the size of the motor will get increased. And if the size of the motor get increased, then it means that the mechanical losses will get increased, due to which your efficiency will get decreased. Option D is the correct answer. Okay, next MCQs is, when two DC motor operate in series, torque is half produced by motors when in parallel. Torque is double of that produced by motor when in parallel. Torque is 4 times that produced by motor when in parallel. Torque is 8 times that produced by motor when in parallel. So actually, the torque is directly proportional to flux times Ia. So in case of series, so this is my motor 1 and this is my second motor. So if you connect both motor in series, then the same current will flow. Ia will flow. Ia will flow in M2 as well. And similarly, same flux will be in both motor. But if you connect the motor in parallel, let's say this is my M1, this is my M2. So here the current will be Ia. So here the current will be Ia divided by 2, and here the current will be Ia divided by 2. So current will get split up. So the flux will also get half. So you can say that the torque will be directly proportional to, in case of series, series will be, this will be flux times Ia. In case of parallel, that will be flux times Ia divided by 4. So you can say that your torque in series will be equal to 4 times the torque in parallel. So when two DC motor operate in series, torque is 4 times that produced by motor when in parallel. So option C is the correct answer. Okay, next MCQs is, if the flux of a DC motor approaches zero, its speed will approach zero, its speed will remain unchanged, the motor will stop, the motor will tend to run at infinite speed. So actually we have inverse relation of speed and flux. So if you decrease the flux up to zero, then your speed will be approximately equal to infinity. So the motor will tend to run at infinite speed. So option D is the correct answer. Okay, next MCQs is, the duty cycle of a motor is given to us, and the continuous rating of a motor suitable for the above application would be 20 kilowatt, 16.4 kilowatt, 14.14 kilowatt, 9 kilowatt. So actually, first, what is mean by continuous rating of motor? So continuous rating of motor is the maximum output that a machine can supply without exceeding a specific temperature rise. So here load is given to me and the duration is given to me. So the continuous rating will be equal to, that will be equal to your load 20 square times 120 seconds plus 10 square times 120 second divided by 120 plus 120 plus 280 divided by 3. Why we are dividing this by 3? Because this is according to American standard. So, and also there is a square root. So if you simplify this, then you will get 14.14 kilowatt. So option C is the correct answer. Okay, next MCQ is, if the applied voltage of a DC shunt motor is half with the load torque doubled, the armature current will. So actually we have a well-known relation, that is the torque is directly proportional to the flux times armature current. So if you double the torque, then the armature current will also get double. So option C is the correct answer. Okay, next MCQ is, change in speed of motors under wall Leonard control occur due to change in armature voltage of DC motor, armature current of DC motor, field excitation of DC motor, supply voltage. So I discuss in detail about this. So that is the armature voltage of DC motor. Okay, next MCQs is, speed control by a wall Leonard method is available in one direction only, in both direction through RS switch. I discussed in detail about this in last MCQ. Through RS switch, you can change the speed of DC motor. So option B is the correct answer in both directions. So next MCQ is, for which application a DC motor is preferred or an AC motor? Low speed operation, high speed operation, variable speed operation, fixed speed operation. So that is the variable speed operation. So for variable speed, we prefer a DC motor as compared to AC motor. So this is the end of this video. Thanks for watching. And if you have any question, you can post it that question in the comment box. And if still you did not subscribe my channel, then kindly subscribe my channel. Thanks for watching. Allah Hafiz.